Hi everyone, today I'm going to be going through the 2012 Intermediate Australian Maths Competition. Questions 20 to 30. Question 20. Pippa made a litre of drink from apple juice and water in the ratio of 1 to 2. She found the taste too strong, so she made a litre again in the ratio 1 to 3, but found this too weak. She thought if she combined these two mixtures it should be about right. What is the ratio of apple juice to water in the new mixture? So in drink 1 it has a third litres of apple juice and 2/3 litre of water, and in drink 2 it has a quarter litres of apple juice and 3/4 litres of water. So combining this, we add the apple juice, a third plus a quarter, and the water, 2/3 plus 3/4, and then when we simplify this we're going to get 7 over 17, so the answer is D. Question 21. A courier company has motorbikes which can travel 300 kilometers starting with a fuel tank. Two couriers, Anna and Brian, set off from the depot together to deliver letters to Connor's house. The only refueling is when they stop for Anna to transfer some fuel from her tank to Brian's tank. She then returns to the depot while Brian keeps going, delivers the letters, and returns to the depot. What is the greatest distance that Connor's house could be from the depot? So here we have the depot, here we have the transfer point where Anna transfers fuel to Brian, and here we have Connor's house. So Anna travels to the transfer point and back, a distance of 2x. Brian travels a distance of 2x plus 2y, all the way here and all the way back. So if all 600 kilometers of fuel is used, 2x plus y equals 600, and we get one equation here we can use. We also know that on a full tank the max Brian can travel is 300 kilometers, which means that y plus x can be a max of 300, which gives us another equation to work with, and adding these together gives us x plus y equals 200. So the answer is B. Question 22. QRST is a trapezium in which QR is parallel to TS and QR to ST equals 2 to 3. If the area of triangle XST is 18, what is the area of triangle RTS? So triangle QRX and TXS are similar, therefore K equals 2/3 H. We're given that the area of triangle XST is 18, which has a base of 3a and a height of h, so the areas are half times 3a times h, and we can get 8h equals 12. Now if we look at triangle RTS, it again has a base of 3a, but now the height here is equal to k plus h. And then here we can substitute in AH equals 12, which we calculated here. And solving this gives us 30 square units. So the answer is C, 30. Question 23. If ABC plus AB plus BC plus CA plus A plus B plus C equals 104 and A, B, C are positive integers, then what is A squared plus B squared plus C squared? So this question is a matter of factorizing this expression. When we do this, we're going to get A plus 1 times B plus 1 times C plus 1 equals 3 times 5 times 7. So A, B, C in some order are 2, 4, and 6. And then 2 squared equals 4, 4 squared equals 16, 6 squared equals 36, and adding these up gives 56. D. Question 24. A teacher has a class of 12 students. She thinks it would be a nice idea if they changed desks every day, so she has painted arrows on the floor from desk to desk. Each desk has one arrow going to it and another going from it. Each morning the students pick up their books and move to the desk indicated by the arrow. By choosing her arrows carefully, the teacher has arranged it so that the longest possible time will pass before all students are back in their original desks at the same time. How many days is that? So this one was quite tricky. The students have to be divided into a number of cycles with the lowest common multiple of these as large as possible. For one cycle we have 12 days. For 2 cycles co-prime we have 5 and 7 giving 35 days. For 3 cycles co-prime we have either 2, 3, and 7 giving 42 days, or 3, 4, and 5 giving 60 days. 4 or more cycles doesn't improve this, so the maximum is 60. D. Question 25. The number 33 to the power of 33 can be expressed as the sum of 33 consecutive odd numbers. What is the largest of these? This can be solved by considering the middle number x. The 33 consecutive numbers are then x minus 32 through to x plus 32. The sum of these numbers is 33x. So 33x equals 33 to the power of 33, x equals 33 to the power of 32, and then the largest number is x plus 32. So 33 to the power of 32 plus 32, giving us A. Question 26. Slim took a long road trip across Australia over a number of days. When he arrived at his destination, he noted that he had travelled exactly 2,012 kilometres. On the first day, he travelled a whole number of kilometres, and each subsequent day he travelled 1 more kilometre than the previous day. What is the largest distance in kilometres that he could have travelled on the first day? So if we let the distance travelled be d, and he travels for n plus 1 days, then d plus 1 plus d plus 2 through to d plus n equals 2012, and n plus 1 times d plus 1 through to n equals 2012. Then the sum of 1 to n is n times n plus 1 over 2. And then we keep working through this, and we get n plus 1 times 2d plus n equals 8 times 503. If n is odd, 2d plus n is odd. If n is even, then n plus 1 is odd. So one factor is odd and must be 503, and the other is 8. Since n plus 1 is less than 2d plus n, then n plus 1 equals 8, n equals 7, and d equals 248. So that's the answer, 248. I verified this with Python code, and also got the same answer, 248. Question 27. 5 consecutive positive integers, p, q, r, s, t, each less than 10,000, produce a sum which is a perfect square, while the sum q plus r plus s is a perfect cube. Find the value square root of p plus q plus r plus s plus t. Let the 5 consecutive integers be r minus 2, r minus 1, r plus 1, and r plus 2. Then 5r equals m squared, and 3r equals n cubed for some integers m and n. Then r equals 5u squared equals 9v cubed for some integers u and v. So 5u squared equals 9v cubed. And since 9 isn't divisible by 5, v cubed isn't divisible by 5. But as 5 is prime, then v is divisible by 5, and v cubed is divisible by 5 cubed. So 5u squared equals 9 times 5 cubed, or 125, times w cubed for some integer w. Then u squared equals 9 times 25w cubed equals 3 squared times 5 squared times w cubed for some integer w. So w cubed is the square of an integer, so that w equals y squared for some integer y. Then u squared equals 225 times y to the power of 6, and r equals 1125 times y to the power of 6, and when y equals 1, that's just 1125. When y is greater than or equal to or 2, we get an impossible scenario. Well, because they're less than 10,000, and this would be more than 10,000. So when we put y equals 1, we get r equals 1125. And now we can calculate this, and we get 75. I also wrote some Python code. So instead of finding r, I found p, which is r minus 2, which is 1125 minus 2, which is 1123, like here. and also got the final answer 75. Question 28. A quadrilateral with sides 15, 15, 15, and 20 is drawn with each vertex on a circle. Around this circle, a square is drawn, with each side tangent to the circle. What is the area of this square? So we have a circle with center O, the trapezium inscribed, and the square xscribed. First, we look at this triangle here. Now, to get this length, we know from here to here is 10. From here to here is 15 divided by 2, which is 7.5. And we do 10 minus 7.5 equals 2.5. Now this is using Pythagoras. H squared plus 2.5 squared equals 15 squared. And this lets us solve for h, which we'll use later. Looking at this triangle, this is the radius of the circle. I called this x, and this is 10. So we can solve for x. So now we have h and x. We substitute in h and x over here. And this is from this triangle here, with side length h minus x, 7.5, and r. Now when we expand this, we get this. Then I took the square root of the top and bottom of this fraction. Now the 2's cancel here. And then continuing on the next page, we keep solving for r, eventually getting r equals the square root of 135. So the side length of the square is 2r, so the area is 2r squared, which is 4 times 135, giving 540 square units. Question 29. In the grid shown, we need to fill in the squares with numbers so that the number in every square, except for the corner ones, is the average of its neighbors. The edge squares have 3 neighbors, the others 4. What is the value of the number in the square marked x? So there's only one solution, like so. And then y has 3 cells that are its neighbors, x and 1,000 and 0, so x plus 1,000 and 0. And then x has 4 cells, 0 plus y gives us 2y. And then if we solve this, we're going to get x equals 200 is our answer. Last question. Terry has invented a new way to extend lists of numbers. To terrify a list such as 1, 8, he creates 2 lists, 2, 9 and 3, 10, where each term is one more than the corresponding term in the previous list. So 1 plus 1 gives 2, and 2 plus 1 gives 3. 8 plus 1 gives 9, and 9 plus 1 gives 10. Then he joins these together. So 1 and 8, 1 and 8, 2 and 9, 2 and 9, 3 and 10, and 3 and 10. This is just an example. In the question, he starts with a list containing one number 0, and repeatedly terrifies it to create this list, where we've given the first few terms. And now we have to find the 2012 number in this list. So we can observe that the length of a list goes up in powers of 3 at each stage, and each element is the sum of that number's digits in base 3. So we solve it by converting 2012 to base 3, giving 220 to 111. And if we add these up, we're going to get 9 is the final answer. And the authors of this question, I assume, did a bit of a play on words, because it can be solved using the ternary number system, and they called it Terry, T-E-R. I also wrote some code to verify this, and it gives us the 9th number by just calculating all of them. Sorry, the 2012 number is 9. matching our answer here. That brings us to the end. Thank you for watching.